Hello everyone, welcome back to topic 5, Deep Learning for Natural Language Processing. In this topic, we will give an overview and introduction to deep learning for natural language processing. We will give a general introduction on natural language processing, word embedding, and popular neural network architectures such as recurrent neural network and long short-term memory, which give you the ability to build your own deep learning models to solve natural language problems. In the very first session, I want to give a general introduction to natural language processing. I will talk about the basic concept of NLP and various use cases of NLP to our lives and the challenges to perform NLP tasks. Formally, NLP is a specialized field of computer science and artificial intelligence with roots in computational linguistics. It is primarily concerned with designing and building applications and systems that enable interaction between machines and natural languages that have been evolved for use by humans. Hence, often it is perceived as a niche area to work on, and people usually tend to focus more on machine learning or statistical learning. When people started delving into the world of data science, they were overwhelmed by the challenges in analyzing and modeling on text data. However, after people working on several challenging problems around NLP over the years, they have noticed certain interesting aspects, including techniques, strategies, and workflows which can be leveraged to solve a wide variety of problems. The goals of an NLP model can be very far-reaching, such as true text understanding and real-time participation in spoken dialogues, that really requires NLP model to have human-level performance. Alternatively, people can develop NLP models for very practical purpose, such as classify a text into one of the predefined categories or extracting keywords from a bunch of documents. The first example of NLP application is question answering. Question answering is a critical NLP problem and a long-standing artificial intelligence milestone. Q&A system allows a user to express a question in natural language and get an immediate and brief response. Q&A systems are now found in search engines and phone conversational interfaces, and they are fairly good at answering simple snippets of information. On more hard problems, however, these normally only go as far as returning a list of snippets that the users must then browse through to find the answer to our question. Reading comprehension is the ability to read a piece of text and then answer questions about it. Reading comprehension is difficult for machines because it requires both natural language understanding and knowledge of the world. In order to train a Q&A system, the model usually learns from a huge reading comprehension dataset, such as the one developed by Stanford University NLP Lab. This dataset is made up of questions on a collection of wiki articles, with the response to each question being a text segment or span from the relevant reading passage. The purpose of the model is to locate the text for any new question that has been addressed, as well as the context. The BERT model developed by Google is a popular choice for question answering tasks. The second example of NLP applications is sentiment analysis. Sentiment analysis, also known as opinion mining or emotion AI, is a subfield of NLP that tries to identify and extract opinions within a given text across blogs, reviews, social media, forums, news, etc. Sentiment analysis can help craft all this exponentially growing unstructured text into structured data using NLP and open source tools. For example, Twitter is a treasure trove of sentiments, and users are making their reactions and opinions for every topic under the sun. Sentiment analysis helps data analysts within large enterprises to gauge public opinion, conduct nuanced market research, monitor brand and product reputation, and understand customer experiences. In addition, data analyst companies often integrate third-party sentiment analysis APIs into their own customer experience management, social media monitoring, or workforce analytics platform in order to deliver useful insight to their own customers. Basic sentiment analysis of text document follows a straightforward process. First step, we break each text document down into its component parts, such as sentences, phrases, tokens, or parts of speech. Second step is to identify each sentiment-bearing phrase and component. Last step, assign a sentiment score to each phrase and component between -1 to 1, and then combine scores for multi-layer sentiment analysis. Next, name entity recognition. Name entity recognition, short for NER, is probably the first step towards information extraction that seeks to locate and classify name entities in text into predefined categories such as the name of persons, organizations, locations, expression of times, quantities, monetary values, percentages, etc. NER is used in many fields in natural language processing, and it can help answering many real-world questions, such as which companies were mentioned in the news article, were specified product mentioned in complaints or reviews, does the tweet contain the name of a person, does the tweet contain this person's location. In simple words, name entity recognition is the process of detecting the name entities such as person names, location names, company names from the text. With the help of name entity recognition, we can extract key information to understand the text, or merely use it to extract important information to store in a database. One big use case for name entity recognition is customer support. For the use case of customer support ticket, where we deal with a rising number of tickets, there we can use name entity recognition techniques to handle the customer request faster. From a business perspective, if we automate the repetitive customer service task, such as categorizing customers' issues and queries, then it saves you valuable time. As a result, it helps to improve your resolution rates and boost customer satisfaction. Here, we can also use name entity recognition to pull the relevant pieces of information, like product names or serial numbers, which makes it easier to route ticket to the most suitable agent or team to handling that issue.